Hi guys, and welcome to my channel. My name is Abba Edziba and I am a maths lecturer. Now, I am hoping that my educational development channel can help you understand more about your mathematics, your science, and I'll be collaborating with some great friends of mine to bring you English as well. Now, these are turbulent times that we're facing, and the prospect of staying home for so long can mean you can lose touch with some of the basic things that you've had a grasp on for years, or not even know how to develop things further and take things just a little bit further in terms of your education. Well, I hope that I can help you on that journey. Now, whether you're watching this video because you're bored, because your parents told you to, or because you decided to develop your education yourself, welcome. I hope that these videos are creative, that they're practical, and that they're quite simplistic in the way that I break down the topics in order to be able to help you stay on top. What I hope that I'm going to be able to do with you guys today is just talk about an introductory topic on shapes. I love geometry, and trust me, you're going to see that quite a lot. But I just wanted to talk about shapes because shapes are something that we come into contact with every single day. You hold shapes, you see shapes, you draw shapes in different ways. But do we really know the different types of shapes, how to categorize them, and what properties each of them possess? Let's find out. So, two main types of shapes that you need to be aware of. We've got the two-dimensional shape and we've got the 3D shape. But this word two-dimensional, three-dimensional, what does it really mean? A dimension is simply a length. Now, we have got a length and a width when we're dealing with two-dimensional shapes. We've also sometimes hearing the phrases height, breadth, but all of these are different ways of describing a dimension of a two-dimensional object. Now, what does 3D mean? Same thing, but we've just got 3 dimensions. But that third dimension makes it easy for us to pick up, something like a calculator. Okay, I can hold it 3-dimensional. Whereas if I was to just draw a circle, I can't actually hold that circle unless I draw it on a piece of paper and cut it out, and the paper is 3-dimensional. So, how can I distinguish the different types of 2-dimensional shapes and 3-dimensional shapes? Let's start with the basic 2-dimensional shapes. Now, we can split the word shape even further into 2 particular categories: polygons and shapes. A polygon is a 2-dimensional shape that only has straight sides. Now, a lot of people are not aware of this actual definition and the differentiation between the two. A circle is not a polygon, but a circle is a 2-dimensional shape. A triangle is a 2-dimensional shape, but more specifically, it is a polygon. So we're going to leave just 2-dimensional shapes such as circles and semicircles to one side, and let's focus on the polygons. Because trust me, the exam boards want you to know about polygons. So we have got a whole range of polygons that we need to know about, starting from a 3-sided polygon all the way up to a 10 or even sometimes 12. Now we're just going to focus on the first 2 groups, which are the 3-sided and the 4-sided, but you do need to be aware of the other types of polygon. 3-sided is called a triangle. A lot of people are aware of this, but do you know the different types of triangle? The second group of polygons are the quadrilaterals. Now, a lot of people struggle to say that word, and trust me, it's not an easy word to say. Let's just call them the quads. Quad means 4, so therefore quadrilaterals have got 4 sides. A 5-sided polygon is called a pentagon, 6-sided is called a hexagon, 7-sided is called a heptagon, 8-sided is called a octagon, 9-sided nonagon, 10-sided decagon. Be aware of the different names given to the different types of polygon, but remember the 2 main groups that you need to be aware of are the triangles and the quadrilaterals. So let's take a deeper look. Each triangle has got specific properties that allow us to be able to identify it. So, the first triangle is the equilateral triangle. Equal, the word equal means the same. Now, that will tell you that in an equilateral triangle, things are pretty much the same. We have 3 sides of equal length, 3 angles of equal size. We can also go on to say that we have 3 lines of symmetry. We'll get into that a little bit later. The next triangle is the right angle triangle. Now, a right angle is a 90-degree angle. If you were fully aware of how angles work, 90 degrees can sometimes be drawn like this. Now, in a right angle triangle, we have one angle which is 90 degrees and we have 2 other angles, and the sides can be different lengths. In an isosceles triangle, we have 2 sides the same length and 2 angles also of the same size. Finally, we have the scalene. I don't know where the name scalene came from. Don't ask me. Maybe Google it. But scalene triangle has got no equal angles, no equal sides. It's the odd one out. So, recap. 4 types of triangle: the right angle, the equilateral triangle, the isosceles triangle, and the scalene. Make sure you know their properties. Now, I didn't mention to you that when we're categorizing our shapes, we use 2 specific words to describe what kind of polygon we are talking about. Is it a regular polygon or is it an irregular polygon? Regular means that everything is kind of together, kind of equal, the same. So you would expect same sides, same angle sizes. In an irregular shape, we have differing lengths of the sides of a polygon and differing angle sizes. So when we're talking about a regular triangle, there is only one triangle that fits the bill, the equilateral triangle. 3 equal sides, 3 equal angles. That's our first regular 2-dimensional polygon. Now, it's also important to note that the sum of the interior angles of each triangle is 180 degrees. Let's get on to the second group of polygons. The quads. I love the quads. Honestly, there are so many of them. They've all got individual properties. But what I've noticed, especially with some of my learners, is mixing up the actual definitions of the quads. So let's start with the first quad that I'm sure we've all come across, the square. Now, what makes a square a square? Not the fact that it's square, but a square has got 4 equal sides, 4 equal angles. That's how we can determine whether a 4-sided shape is a square. Are all the sides the same length? Are all the angles the same size? Now, a rectangle has got 4 angles the same size, but the opposite sides are the same length. Opposite means facing. So if I take a 2-dimensional shape that has got 4 sides and the opposites are the same length, I have a rectangle. Next, we have what is known as the rhombus. Interesting spelling. A rhombus is what I like to call a squashed square. Now, we've already gone through the properties of a square. Therefore, this should be a little bit easier to be able to work out some of the properties of the rhombus. In a square, what did we say? A square has 4 equal sides, 4 equal angles. Now, if I was to squash a square, would the sides change length? No, they would not. So a rhombus has 4 equal sides. But would my angles change? Yes, they would. Two of the angles are going to become smaller, two of the angles are going to become bigger. So a rhombus has got all sides the same length, but the angles opposite each other are now the same size. The rhombus has a cousin. Now, this cousin is called the kite. Now, many of us have seen a kite being flown, or you might have seen it on a video, and we know what it looks like. But the kite is actually the name given to a particular shape. And the kite looks like this. Now, do you notice how it's a little bit different to the rhombus? In the fact that the sides that are touching are the same length, but not all four sides are the exact same length. Next, we have got the parallelogram. Challenge for you. Say parallelogram 10 times. What is a parallelogram? Four-sided rectangle pushed over. Okay, so we take the rectangle, or we push it over, we get a parallelogram. That's it. So when you see a shape in which the opposite sides are the same length, but they're pushed over, it's a parallelogram. Do note that the word parallel has been included in its name, meaning that we have to take into consideration, what does parallel actually mean? Parallel means two sides that will never meet. Have you ever met somebody and you just wish somehow that your paths will cross, but you know your paths will never cross in a lifetime? Yeah, you guys are living parallel lives. But yeah, on a real note, parallel means that we have got the exact same distance between two lines if we were to continue for eternity. Those lines will never, ever, ever meet. So a parallelogram is a pushed over rectangle. We've got a square, four sides of equal length, four angles of equal size. A rectangle, opposite sides the same length. Rhombus, squashed square. And now we move on to, last but definitely not least, the trapezium. Now, what is a trapezium? It's like the odd one out of the family. It's like, I don't know how to describe the trapezium. It has one pair of parallel sides. That's it. Four-sided shape, one pair of parallel sides, trapezium, done. And that's how quadrilaterals. Now, do be aware of the pentagon, do be aware of the hexagon, the heptagon, octagon, to be able to identify the number of sides that those polygons have. But you need to make sure you can home in on those triangles and those quadrilaterals. Now, let's talk about three-dimensional shapes. 3D shapes, this is what I actually like, because I think this is a little bit more practical. When you understand the fundamentals of the two-dimensional shapes, it's a little bit mundane, but once you get the hang of it, it makes the three-dimensional shapes a lot easier to grasp. So, recap, three-dimensional shape, 3 dimensions, we've got length, we've got width, we've got depth, we can hold it, it is 3D. Now, I'm sure our cupboards these days are full of tins. First three-dimensional shape we are going to talk about today is the tin. No, I lie. It's the cylinder. Now, the tin is in the shape of a cylinder. We have got two circular faces. What is a face? Face is the flat part that you can put your hand on, basically. Can you run your hand on it? It is a face. So, a cylinder has got two faces, and then it's got this body. Now, it has got a consistent area all the way through. What do I mean by area? We're going to look at that in another video, so do check out that link when that link is up, and it will be out later this week. But the cylinder, if I was to cut it through, I would still have a circular face all the way through its length. And that's where the cylinder actually falls into a group of three-dimensional shapes that we call a prism. Pause on that, we will get back into prisms. But this, a tin, is a cylinder. Jacked my mum's box of OXO cubes. Seasoning. Now, this three-dimensional shape has got rectangular faces. How did I know that the faces are rectangular? Well, opposite sides are the same length, therefore, and it has 4 sides, so therefore it is a rectangular face. Can I touch it? It's a face. Now, basically a three-dimensional rectangle is called a cuboid. Not a cube, a cuboid. Now, one of the things that gets underneath my skin is when students mix up a cuboid and a cube. But let's try and settle that beef right now. Got the OXO out now. Square faces, 4 sides of equal size and proportion. This is a cube. A dice is a cube. So be careful in being able to distinguish between a cube and a cuboid. Okay? Now, we all know what a pyramid is. And I want to give you a very practical example of a triangular prism. The examiners love these prisms. They want you to find the volume of them. They sometimes want you to find the area of the face of them, which we will be doing in another video, like I said. Let me give you a practical example of a triangular prism. Toblerone. We love the Toblerone. Look at that shape. Look at it. Beautiful. The box is a triangular prism. Now, obviously, the actual Toblerone inside is not, but it's more formed of pyramids all stuck together. But that box is a perfect example of a triangular prism in real life. So every time you guys see a tin, know Mum's stocked up on a whole pile of cylinders. When you're looking at the toilet roll situation, classic example today. I mean, it's a precious commodity right now, right? Yeah, those are some precious cylinders right now. Example of a cylinder. Cylinder with a hole in it, but it's still a cylinder. OXO cubes, perfect example of a cube. Dice, for those board games that I'm hoping you guys are going to start playing now. I mean, we're all in the house. I mean, what else is there to do? A little bit of Scrabble, a little bit of Monopoly. Monopoly is a very, very, very aggressive game, mind you. I mean, when you really get into it. We've got cuboids, which are rectangular shapes. So all of your boxes, cereal boxes, guys, please make sure you don't finish all of the cereal in 1 week. Make sure that it does last, okay? And we have got others. The ball is a sphere. Try and say that with me. Sphere. That is its actual mathematical name. Now, that has a very interesting way of calculating the volume, so how much it actually holds. That's what I mean by volume. And we'll be looking at how to calculate area and volume definitely in another video. Well, I'm gonna go and grab something to eat now. I hope you guys have been able to understand a little bit more about 2-dimensional shapes, 3-dimensional shapes, some examples of where you see them in your house today. I'm going to be coming back in 2 days' time with another video on area and volume. Stay tuned. Make sure you check out the links and make sure you comment and subscribe. See you soon.